Hello, my name is Chuck Trotwine, and I'm going to take a few minutes to talk about using Scratch to teach mathematics, specifically um, looking at modeling fractions with Scratch and sort of taking students' knowledge that they've gained about coding through code.org and activities like that and actually apply it to the teaching and the learning of mathematics. This session is not so much about coding. It's going to be the application of coding as a tool for sort of turning this Bloom's taxonomy upside down. And so we can spend some time on the higher levels of generalizing and applying and creating knowledge and reaching the transformational levels of the SAMR model, the modification and redefinition levels. If you're not familiar with the SAMR model, it's a great model. We use it in Garrett County to, teachers use it in Garrett County to kind of self-assess how they're doing with their application of digital learning in their classrooms. Okay, so let's get started. Let me give you an overview of what we want to do here real quick. Normally I would do this in a class, the third, fourth, fifth grade, and it takes about 40 minutes, 30 to 40 minutes. It's more of a whole group activity. It's a I do, you do type thing. I usually use a projector and smartboard, and students usually are in pairs, or each student has their own computer and follows along with what I'm doing on the screen. So the idea here is to apply their knowledge of fractions to teach this little guy here, Scratch, how to, first of all, make a whole unit and then divide it into as many equal parts as the user would like. So let's go ahead and run the Scratch here. If you're not familiar with Scratch, this part here is called the stage. Here we have all kinds of Scratch commands, and here we have a place to build our scripts or our code. The little guy here's name is Scratch, of course. Okay, so let's go ahead and click up here, this block of code. Scratch is asking how many equal parts, and I'm going to type in 4 equal parts, and he's going to put in 4 equal parts. Pretty cool. Let's do it one more time. Click over here in the code. How many equal parts? I'm going to say 8, and he's going to do 8 equal parts. So clearly we can take this whole unit and divide it into as many equal parts as possible, as well as the user would like. Okay, so let's go through this. Generally, what I would do in a classroom is I'd have a, hopefully I would have a whiteboard as well, or a chalkboard. And so I'm going to kind of use this space here, this Google Drawing doc, as my whiteboard. Okay, so I'm going to concentrate on the stage here, and that's where all the action is going to take place. And what we want Scratch to do first off is to draw a unit rectangle. Now, we want this unit rectangle to be dimensions of 400 units across the bottom and 50 units across the top. Now, what's the units? Well, of course, we're talking about Scratch, so they're going to be Scratch steps. Okay, so 400 Scratch steps across the bottom, 50 high here on the rectangle, unit rectangle. Scratch always starts in the center of the stage. So Scratch is going to start sort of right there. And the stage has a coordinate. The stage is built on a coordinate system. So as you would imagine, Scratch starts at x, x0, y0. So sort of here, real quick, here I have the stage as a coordinate grid here, so you can see center is 0, 0. It goes up to 180, y goes down to negative 180, and of course x goes to negative 240 and to 240 positive in the positive x direction. So I just wanted to show you that, how you can see the stage as a coordinate grid. A little bit of a stretch for third grade, talking about negative numbers here, but they get the hang of it pretty well as being just the opposite of the way Scratch is pointing. Okay, and we'll talk about that in a little bit. The big concepts here is the left and right direction is the x direction, and of course if you go opposite, the way Scratch is pointing, or go to the left. In this case, it's going to be negative and positive if you go to the right, and so on with the Y direction. It's up and down. Is down usually is negative, and up is usually positive. But again, we'll talk more about that through this little demonstration. Okay, so the first troll we have is to get Scratch to draw this rectangle. He starts at x0, y0, or 0, 0. What we'll have to do is we'll use turtle commands or Scratch commands to go ahead and have Scratch create this rectangle. What Scratch has is a pen strapped to his backside here. Anywhere Scratch moves, if the pen is down, he will draw a line. So that's how we're going to draw this rectangle here. So he's going to start here, but what is that? So we have to move Scratch from 0, 0, and we have to move him to this, whatever this coordinate is here. So we can use a little bit of math here and say, okay, so he's right in the center. So we have to go this way 200 units, and then we have to go down this way. Let's say half of 50 is 25 units. So relative to 0, 0, that would be negative 200 and y negative 25. And that would be that position right there. And so we move him there when we issue that command. Okay? Again, a little bit of a stretch. You might want to have a conversation with your students about the meaning of negative numbers. I usually major on negative being the opposite. Okay, so if you have a positive integer, a negative integer is the opposite of its positive. There's all kinds. It's surprising how easily third grade students catch on to that concept. Okay, so let's go to Scratch, and we'll start from scratch with Scratch. I usually like to use the online version because that's where all my cool stuff is. So you just Google Scratch. I'm a user there. My handle is Old Math Teacher, so you might want to look me up and see some of the other things that I've done with Scratch with students here in Garrett County. Okay, I'm just going to go ahead and click Create, and it gives me a new Scratch. This is an amazing product. This is my 35th year teaching, and when I started teaching mathematics 35 years ago, 34 years ago, is when we got our first computer in my classroom. One of the first things I learned about was Terrapin logo. And of course, logo is a little turtle that you move on the screen using turtle commands. It was created by the folks up at MIT. And so this is what Terrapin logo has evolved into. So it's just such a cool environment for creating in modeling different concepts in mathematics. It gives students sort of like I'm going to put this in quotes, math land, unquote, math land that they can explore mathematics in. It becomes their real world that they're exploring in your classroom. Okay, so here's Scratch. He's on the stage. I'm going to go ahead and shrink him down, okay, because he's just taking too much of the stage up here. So I just shrink him down. To do that, you want to go to shrink, click that once, then just click this guy 10, 12 times, and he shrinks down. Okay, so without much to do here, the first thing we want to do is make sure that Scratch's pen is up. So we're going to put his pen up because we're going to move him, and when we move him, we want him to draw a line. Yet, okay. Then let's go to motion commands, and we're going to move Scratch, and this is all just setting him up to draw the rectangle. That's that's our first little task here. And you want to make sure students know what's going on. You know, it's like just don't have them blindly follow you. You want to make sure that they know what's going on, and let them lead a little bit. Okay, so go to X, what do we say? Negative 200, and Y is negative 25. That gets them somewhere down here. You see these coordinates are down here, wherever your pointer is. You can see about where you're at as far as on the coordinate grid. The other thing is It's really important to know that which direction Scratch is pointing in, because he's going to, if you move him, especially when he's drawing a line, he's going to move forward in the direction he's pointing. Right now he's pointing in the 90-degree direction straight across the screen towards my pointer here. So, but sometimes he might get a little bit turned up or down or left or right. So let's go ahead and I'm going to say point in direction 90, and that's the direction he's pointing now. Some basic setup there. And you'll pretty much start any Scratch with a similar set of commands here, Scratch or blocks. Okay, so now what we want to do is we want to move, no, before we move, we want to put his pen down. And now we want to start creating the rectangle. So let's go to motion commands. His pen's down. Anywhere he moves, he's going to draw a line. I'm going to move forward. What do we say? The bottom of the rectangle was going to be 400 units or 400 Scratch steps. All right, now the neat thing about Scratch is you can test your code as you build it. So I'm just going to run this. To run it, I'm just going to click on this block of code, and bing, it's got the bottom part of the rectangle down. Now, Scratch only draws a line in the direction that he's pointing. Before we draw the next part of the rectangle, we have to turn Scratch. All right, so we have to turn him not 15 degrees, but 90 degrees. And we can have a discussion with third and maybe fourth grade as to what 90 degrees are. Is a right angle. Fifth grade should know that. Maybe fourth grade should know that as well. Okay, let's see. Then what we need to do is after we turn, you don't have to test this after every block. Yes, go ahead. All right. Okay, there he goes. So what he did is he did everything really quick. he went to negative 200 and negative 25. He put his pen down and moved real quick. All right, one thing else that we should have done in the very beginning is to clear the screen. All right, so let's go and clear the screen. But let's clear the screen not at the very beginning, but let's pop this in between point in direction 90 degrees and his when he first starts to move here to create the rectangle. Okay, now let's go ahead and move him 50 because that's the next dimension of the rectangle. And let's see what happens. Yep, so we did that really quick. And so he drew this. You don't believe that here. You don't believe me. I'm going to clear the screen. Clear the screen. Now let's try it. There he goes. Okay, did it quick. All right, now before we draw the top part of the rectangle, we have to turn him again, right? So let's go to motion, set of commands. Turn again, counterclockwise or to the left, and 90 degrees, a nice right angle. Let's see what happens. Clear the screen. There he goes. Now he's ready to do the next side, so we're going to go move 400 steps again. But see, this is where having the code.org experience, having your students have the code.org experience comes in handy. Because what they'll say is, well, Mr. Troutwine, we're just going to do all these 4 blocks again in order to make the second half of the rectangle. And so they say, just use the repeat command. I said, well, that's a good idea. So let's go up to control, and there's the repeat block. So I'm going to click and drag the repeat block and kind of gobble up all 4 of these commands. And instead of repeating 10, we're going to repeat 2. And then let's go ahead and run this. And ta-da, we got our unit square, or our unit rectangle. I'm sorry. All right, so pretty cool. Let's go back to where we were, our whiteboard here. And you can see that we were successful in accomplishing drawing this unit rectangle. Okay, now let's go ahead and decide that we want to divide this rectangle into 4ths. Okay, that's a good benchmark fraction there. Okay, 1/4. So I'm just going to approximate this. Of course, Scratch will get it exactly. Okay, so but anyways, what we have to do is kind of figure out how far we want to move Scratch from here to here in order to draw our first dividing line here. All right, so let's move this right. There we go. So we have to figure out how far to go from here to here, and that's a good discussion to have with your students. They'll tell you it's going to be 100, and you'll ask them, well, how did you get that? And they'll say, well, hopefully they'll say they took 400 and divided it by 4 and got 100 units. Okay, very good. It's really important that they understand why it is 100 and the operation they use in order to get there. And you'll see that here in just a little bit. Okay, so we're here. We're just right where we're going to be. I'm going to go to motion. I'm going to move, what do we say, 100 steps? And then after we move 100 steps, he's going to be somewhere around here. And then we're going to go ahead and say, okay, let's draw this line going up and down. Now, we could use the motion commands and turn him left 90 degrees, then go forward 50 steps, and then go forward negative 50 steps, and then turn him so he's pointing this way to get ready to be in position to make the next dividing line. But there's a really cool scratch command, motion command called change y and change x by a certain amount. So it's not set y, we want change y, and that's change relative to the position that Scratch is at now. Okay, so I'm going to change y by, this way I don't have to turn him. He can just go up and hop up and down, sort of like change him by 50, and then we're going to change y by negative 50. Okay, negative 50. And that's going to draw the first division mark, I think. Let's try them out. Okay. Whoop, there he goes. First division mark. First divider. Okay. Now, how many equal parts do we want? We want 4. Okay, well, they'll tell you, Mr. Troutline, use the repeat command. All right, we're going to use the repeat command. How many times? Well, actually, we only need 3 dividing lines to make 4. That's a little bit confusing, so let's just put in 4 here. Okay, so we're going to repeat that 4 times. Let's try it, and there we go. We got Scratch drawing a unit rectangle and dividing it into 4 equal parts. And the best thing about it, your students know exactly what's going on here because they help you build the code, and chances are they can probably do it themselves again without any help. And they've learned some really cool Scratch commands and how to put them together in order to model some concepts in mathematics. Okay, we're not finished yet. Okay, suppose we want to make divide this into say tenths. Okay, well, what do we have to change? Well, let's see. We don't have to change anything here because the unit rectangle is going to always be the same. But here we're going to, instead of repeat 4 times and divide it into 4s, we're going to divide it into tenths. But then we got to change how far we move because Scratch, remember, is going to start here. So what was the operation? We said 400 divided by 4, so it's going to be 400 divided by 10. So 400 divided by 10 is 40. All right, let's try it. The tenths. Here's tenths. All right. Okay, let's go 6. 6. All right, now, Mr. Troutline. Well, how are we going to do that? We're probably going to need to estimate or use a calculator or something. Well, it turns out that Scratch is really good at doing arithmetic. You just have to tell them the problem to solve. Okay, so let's go to operators. And here we have something plus something, which we don't want right now. Something minus something. Something times something. A little asterisk means times in computer coding. This is something divided by something. That's what we want. So I'm going to pop that in the place of 40. And I'm going to let Scratch do the arithmetic. So I'll let him figure out the nasty repeating decimal here. And so it'll be 400 divided by 6, because that's the number of equal parts. And so let's try it. Pretty cool. All right, 12s. All right, we put a 12 here and a 12 here. And at this point, kids are saying, wow, let's make 50 equal parts. Let's make 100 equal parts. Well, that's good because Scratch, he's good, cheap labor. He'll do whatever you want him to do. You just have to tell him how to do it. Okay, now, one more thing, and that's to make this a little bit more interactive for the user. Let's go ahead and instead of having to change this number and this number, now you have to notice that this number is exactly the same as this number. All right, so if this number changes, this number changes. All right, so let's get Scratch to go ahead, after he draws the rectangle, to go ahead and ask how many equal parts. So I'm going to go to the sensing commands, and here's ask. So this little command will get Scratch to stop and ask a question. We don't want him to ask what's your name. We want him to ask how many equal parts. Excuse my use of the equal sign there. Okay. How many equal parts and wait. So Scratch is going to wait for you to type in an answer, and then that answer is going to be put in this little answer bucket right here. Okay, but let's go ahead and run this and see what happens. Okay, how many equal parts? How many equal parts? I'm going to say 4, but oh, look, he made 12 equal parts. Well, why? We said 4. Oh, look here, we forgot. Okay, so after he asked how many equal parts, we didn't do anything with the answer. We just kept 12 here and 12 here. Our mistake, actually, you know. All right, my mistake, not our mistake. All right, so let's go ahead and take this answer where the answer is placed after you type it in, sort of like a bucket or a variable, if you will, loosely speaking. Answer here, and let's go put an answer here. And so whenever we want to refer to the answer, Scratch says, looks in the answer bucket and says, oh, it's whatever number that you typed in. Okay, let's try it again with 4. How many equal parts? 4. Here's 4. Pretty cool. Let's try it again. It's how many equal parts? Let's go 50. There's 50 equal parts. Pretty cool. All right, I think that's all I wanted to do in this particular little segment. Give you a heads up. We're going to continue this in the next part, part 2. And what we're going to do is here, I'll do something like 16ths. There we go. We're going to go ahead and ask after Scratch divides this equal part into 16ths, he's going to ask for a numerator, and then he's going to shade in however many equal parts that we want to build a fraction for. Okay, so that's part 2. Thank you, and good luck when you do this with your students, and have fun.